This is just a cute house from Desperate Housewives or something. What on earth is going on here?
Well, this illustrates the picture of the future that I think is how things will evolve. You've got an electric car in the driveway. If you look in between the electric car and the house, there are actually 3 power walls stacked up against the side of the house. And then that house roof is a solar roof. So that's an actual solar glass roof.
Okay, so that's
a picture of a real. Admittedly, it's a real fake house. That's a real fake house.
So these roof tiles, some of them have in them basically solar power, the ability to.
Yeah, so the solar glass tiles where you can adjust the texture and the color at a very fine-grained level, and then there's sort of micro louvers in the glass, such that when you're looking at the roof from street level or close to street level, all the tiles look the same whether there is a solar panel behind it or a solar cell behind it or not. So you have an even color from the ground level. If you were to look at it from a helicopter, you would be actually able to look through and see that some of the glass tiles have a solar cell behind them and some do not.
Right. You put them in the ones that are likely to see a lot of sun.
Yes.
And that makes these roofs super affordable, right? They're not that much more expensive than just tiling the roof.
Yeah. We're very confident that the cost of the roof plus the cost of electricity, that a solar glass roof will be less than the cost of a normal roof plus the cost of electricity. So in other words, this will be economically a no-brainer. We think it will look great, and it will last. I mean, we thought about like having the warranty be infinity, but then people thought, well, that might sound like we were just talking rubbish. But actually, this is toughened glass. Like well after the house has collapsed, and there's nothing there, the roof the glass tiles will still be there.
Okay, so I think you're rolling. I mean, this is cool. So you're rolling this out in a couple weeks' time, I think, with four different roofing types.
Yeah, we're starting off with two initially, and then the second 2 will be introduced early next year.
And what's the scale of ambition here? How many houses do you believe could end up having this type of roofing?
I mean, I think eventually almost all houses will have a solar roof. Now the thing is to consider the time scale here to be probably on the order of 40 or 50 years. So on average, a roof is replaced every 20 to 25 years. So, but you don't start replacing all roofs immediately. But eventually, if you were to fast forward to, say, 15 years from now, it will be unusual to have a roof that does not have solar.
Is there a mental model thing that people don't get here that there's been, because of the shift in the sort of cost economics of solar power, that like most houses actually have enough sunlight on their roof pretty much to power all of their needs. If you could capture the power, it could pretty much power all their needs, right? You could go off grid, kind of.
Yeah, it depends on where you are and what the house size is relative to the roof area. But yeah, it's a fair statement to say that most houses in the US have enough roof area to power all the needs of the house.
You just have to build the world's largest manufacturing plant and kind of double the world's supply of lithium-ion batteries.
Yeah. So that's the Gigafactory. The progress so far in the Gigafactory. Eventually, you can sort of roughly see that there's sort of a diamond shape overall, and when it's fully done, it'll look like a giant diamond, or that's the idea behind it.
And capable of producing eventually 100 gigawatt hours of batteries a year?
100 gigawatt hours. We think probably more of it, yeah.
Help us picture this. I mean, how many gigafactories, if you like, does it take to get us there?
It's about 100, roughly. It's not 10, it's not 1,000, most likely 100.
There are some innovations in nuclear, modular, liquid, and innovation really stopped in this industry quite some time ago. So the idea that there's some good ideas laying around is not all that surprising. The idea with TerraPower is that instead of burning the part of uranium, the 1%, which is the U-235, we decided, well, let's burn the 99%, the U-238. It is kind of a crazy idea. In fact, people had talked about it for a long time, but they could never simulate properly whether it would work or not. And so it's through the advent of modern supercomputers that now you can simulate and see that, yes, with the right materials approach, this looks like it would work. And because you're burning that 99%, you have greatly improved cost profile. You actually burn up the waste, and you can actually use as fuel all the leftover waste from today's reactors. And so instead of worrying about them, you just take that. It's a great thing. It breeds this uranium as it goes along. So it's kind of like a candle. You can see it's a log there, often referred to as a traveling wave reactor. In terms of fuel, this really solves the problem. I've got a picture here of a place in Kentucky. This is the leftover, the 99%, where they've taken out the part they burn now, so it's called depleted uranium. That would power the U.S. for hundreds of years. And simply by filtering seawater in an inexpensive process, you'd have enough fuel for the entire lifetime of the rest of the planet. So, you know, it's got lots of challenges ahead, but it is an example of the many hundreds and hundreds of ideas that we need to move forward. This Fukushima thing is terrible. It's awful for the people there. There's many reasons why it should have been avoided, both in terms of the initial design. It's a 1960s design, 3 reactors put into service 1971, 1973, 1974. It's an early generation 2 type design, and the emergency plans were quite weak, and the actual execution in the situation was quite weak. The actual effect is clearly going to be very negative. Now, if you compare it to the amount that coal's killed per kilowatt hour, or natural gas, blows up neighborhoods every once in a while, it's way, way less. And it tends to come in these big events, like 25 years ago, Chernobyl, 31 years ago, 3 Mile Island, and now Fukushima. And so it's more visible, and it needs to be improved. Those designs, they never could simulate. They couldn't simulate what would happen. They couldn't simulate the disaster. And the beauty in almost every realm that you'll talk about at this conference is that software simulation changes the game. We sit there and take, there's this funny company, TerraPower, which is a thing that Nathan Myhrvold and I have spun out of his invention group, Intellectual Ventures. And it's a new nuclear design, which on paper is quite amazing. On paper, it's a lot easier to do these things. But when I say on paper, I really mean in a supercomputer where we simulate everything. And so we can simulate Richter 10 earthquake. We simulate 70-foot waves coming into these things. Very cool. And we basically say no human should ever be required to do anything, because if you judge by Chernobyl and Fukushima, the human element is not on your side. Even if all you have to do is circulate a little bit of water over something, a storage pool of spent fuel, all you have to do is keep it underwater. You don't even have to circulate. And yet, because of a variety of things, that turned out to be difficult. So you've got to design something that humans just don't have to be involved in. So it has real potential. It doesn't move at the speed of semiconductors, so the best case is that by 2020, one of these will get built, and then by 2030, you could have hundreds of them. And then, if it's really as economic as we say, and of course, it is CO2 free. That's the easiest part. Then it starts to make a big impact.